Hi guys, so till now we have studied about simple linear regression model and multilinear regression model. But how do we decide whether our model is performing well or not? How do we compare two or more models? So for that we have model metrics. These metrics basically help me decide how was my model's performance. So we all know that there is a predicted value given by the model and the actual value. Now the ideal scenario would be if these two values are equal. That means my predictions are equal to the absolute actual values. But that does not always happen. So there are some metrics that help us evaluate the difference between the predicted value and the actual value. How far are my predictions from the actual value? The first such matrix is known as mean absolute error. So it basically means the actual value subtracted by the predicted value and the mean difference for all the data points. That means for my n data points, what is the actual difference between the predicted and the actual value. Now the plus point of this particular error is that if let's suppose I am trying to predict salary and the salary is in the units of lakhs per annum, LPA, right? In that case, my error will also be in the units of LPA. So it is easily interpretable. That means if I say that my model is off by 2 lakh, that means 2 lakh per annum, that means I can easily interpret how far are my model's prediction from the actual value. So in mean absolute error, it becomes very easy to interpret the error. Secondly, it does not punish the outliers. That means even if there are outliers in my data set and if those errors are high, it will not penalize them separately. So mean absolute error basically helps me understand how far is my data lying from the actual values and the mean absolute error. Second is mean squared error. Here I take the actual value minus the predicted value and square them for all the values. That means here first of all, if the unit of y, that is my output, is LPA, let's say lakhs per annum, my errors unit will become square. So it is difficult to interpret. Secondly, if there are outliers in my data set, it penalizes them very high. Because now what we are doing is first we are differentiating, or first we are calculating the difference of the actual and predicted and we are squaring it also. That means for every error we are punishing the model because we are squaring the error. So this is a little harsh error. The third is root mean squared error. That means just the square root of this term. Here again the benefit is that the unit is back to LPA. That is, the unit of your output is equal to the unit of your error term. So it is easy to interpret. It also does not penalize outliers that much. The last is R square. Now before understanding this, you need to understand that we do not just select one error and calculate it. For every model, we try to calculate all these three errors and try to minimize them. That is, if I am comparing two models, the errors for all these three values should be minimum or should be less. Now what is R square? Before understanding the concept of R square, let's try to understand one thing. Let's suppose we are trying to predict based on the bill amount, I am trying to predict the tip given to the person, right? And let's suppose I have these data points over here. So as we talked in the first class, if I did not have any data, what would be the most easiest answer to say about the prediction? That would be the mean value. That is, whatever is the mean tip, that could be the prediction. Now this model is very, very wrong because you can see how far it is lying from all the actual data points. But this is the base model or the mean model. And now let's suppose we used linear regression and we came up with this line of best fit. This is my linear regression model line. So what does R square mean? It basically means that how is my model performing with respect to the base model? How better is my linear regression model with respect to the base model? So if you understand here, this numerator, this is nothing but my error of machine learning model, and this model is nothing but my error of base model. If you see here, I am saying how far is yi from the mean value of y, right? This is the base model and this is my machine learning model. So using R square, I try to predict the accuracy of my machine learning model by saying how far is my model better than the base model. So if you understand this formula, if the error of my machine learning model goes down, that means this entire term goes down. That means this R square will go up. That means if my error of the machine learning model is less, my R square will be higher. That is why we say that the value of R square should be as high as possible for a model. This basically means the accuracy of the model. Similarly, if the error of my model is high, that means this term will be higher now. That means this entire term will be low. R square will be lower. That means if my model is making more error, it means it is closer to the base model. It is as good as the base model, which means my model is not good enough. R square is low. So R square value ranges from 0 to 1. It should be as high as possible. It should be as close to 1 as possible. And the last metric is MAPE, which is nothing but mean absolute percentage error. That means I am calculating the percentage error with respect to the actual data. It's not used much, so most people prefer the first 4 metrics. But you should also understand that this helps me understand my error term in percentage. What percentage is being, basically what is the error percentage in my data, right? So this is called MAPE. Now one more thing you need to understand is, in my R square, let's suppose 1 minus, let's call it error of ML model divided by error of base model. Now what happens is, when we are dealing with R square, whenever my input variables increase, that is, if I keep on increasing my input variables, my R square will always increase. It is designed like this. But what happens is, let's suppose I add a new variable x6. Now this variable is not at all correlated with my output variable y. This variable is not at all good for my model. This variable does not mean anything to my y variable. It is not related to my output variable. But still, if I include this model, my R square will go up. And that is the flaw of R square. And that is why we came up with a new formula called adjusted R square, which penalizes your model if you include non-relevant features. If you include non-relevant features. That means if I try to include this x6, which is not relevant to the model, which is not related to y, this model is going to affect and my adjusted R square will go down. So remember one thing, that whenever you are including a useless input variable, your R square will increase, but your adjusted R square is going to fall. And that is why adjusted R square is more preferred in terms of accuracy of the model. And this is how the metrics in a machine learning model work. These are the 5 or 6 main metrics of any machine learning model. And now let's quickly see in the last example how to calculate these. So we saw in the last class how multiple linear regression works, and we were trying to calculate our tip size depending on the total bill and the size of the party. So now we had created these intercepts and we got our line of best fit. And using this, we are going to make the predictions on my X test data. If I have to show you YPRED, these are the predictions of my model for Y test. If you see Y test, these are the actual data points and these are my predicted data points. And now if I have to calculate these errors, I just import these errors and I calculate mean absolute error between Y test and YPRED, mean squared error Y test YPRED, root mean squared error Y test YPRED. So these are the errors for my model. These are the errors for my model and these should be as minimum as possible. Similarly, for calculating R square, I will just pass my actual value and predicted value. And for adjusted R square, I just forgot to cover the formula. It is equal to 1 minus r square value n minus 1 divided by n minus 1 minus k, where n is basically your number of data points and k is basically your number of input variables. So if we come back to our screen over here, we can see our total data points are 49, our number of input variables are total bill and your size of the party. So if I calculate using this formula, my adjusted r square value will be less than my r square value. The formula is designed such that if you include any variables which are not very correlated, your adjusted r square will fall. And that is why your adjusted r square value will always be less than r square value. And this is how r square and adjusted r square are different from one another. A very, very important interview question. Remember, n is number of observations in your test data, whereas k value is number of input variables, number of independent features. So these are some of the very important metrics related to linear regression which help you decide how your model is performing and whether you need to improve your model or not. Thank you so much. For more such videos, stay tuned.